Hello everyone, I am Sudeep Dey from Coach Bihar Government Engineering College. So the topic for my today's presentation is FM radio broadcasting. So we all know about FM radio, right? But we don't know about the thing that how the broadcasting of FM radio is being done. So today we will know about that. So we will talk in this whole presentation about FM radio broadcasting presented by Sudeep Dey. So the contents in this whole presentation should be this: introduction to FM radio broadcasting, evolution of FM radio broadcasting, how this FM radio works, block diagrams of some transmitter and receiver, advantages of FM radio, engineering aspects of this FM radio broadcasting, FM radio, also about the FM radio broadcasting and digital communication. Also, there should be the last point, that should be societal impact, and also last but not the least, conclusion. Okay, so now I'm starting the presentation. So here is our first point: evolution of FM radio broadcasting. So this is about the early developments. The roots of FM radio broadcasting trace back to the 1930s when Edwin H. Armstrong demonstrated the concept of frequency modulation. However, it was not until the 1960s that FM radio gained significant popularity as an alternative to AM broadcasting. Right. So now we are going to stereo FM. One of the revolutionary milestone in FM radio broadcasting was this introduction of stereo broadcasting in the late 1950s. Stereo FM brought a whole new dimension to the listening experience, allowing broadcasters to transmit two audio channels, creating a sense of depth and immersion. Like that, we get sounds from two sides, that is called stereo sound. So, we got this thing in stereo FM. Okay, like a great functional sound, that is the stereo FM, right? So, now digital enhancements. With the advent of digital technology, FM radio has also undergone improvements. Digital FM broadcasting, like HD radio, enables multicasting, where a signal station can transmit multiple streams of content, providing listeners with more choices. So here was the all about evolution of FM radio broadcasting. Now, the FM radio works by encoding audio information onto a carrier wave through the process of frequency modulation. So here we will know about how the FM radio works, right? So let's break down how this process works step by step, right? Uh, so firstly, the audio source. The first step in FM radio broadcasting is obtaining the audio content. This can include music, speech, news, or any other type of audio that needs to be transmitted to the listeners. Like you were saying in the mic something, any song or anything you were speaking. So that should be the audio source, that mic where you were speaking, right? So secondly, the signal processing. Before the audio signal can be modulated onto the carrier wave, it undergoes signal processing. Signal processing techniques may include filtering, amplification, and audio compression to optimize the audio quality and remove any noise or interference. So, signal processing is a thing where the audio is gone through, and there it in it takes review of that there is any noise or anything interference, so it removes that things. Okay, so now number 3, modulation. In the modulation process, the audio signal is superimposed onto a carrier wave. The carrier wave is a high frequency electromagnetic wave generated by the radio transmitter. The frequency of this carrier wave remains constant, while its amplitude and phase are unaffected by the audio signal. So here that audio signal that which is being done with that signal processing, and then it gone through the modulation part. So it modulates with another high frequency wave, which is an high frequency electromagnetic wave, right? So and it is done by the radio transmitter. The like we had also listened about that transmitter block diagram, and we will see that after this. So here we gone through the modulation. Okay, now in the fourth part we will go through the frequency modulation, right? So frequency modulation involves varying the frequency of the carrier wave according to the amplitude of the audio signal. When the audio signal has a higher amplitude, the frequency of the carrier wave increases, and when the audio signal has a lower amplitude, the frequency decreases. Right? The frequency deviation from the carrier wave's original frequency is proportional to the amplitude of the audio signal. So we understood this thing, right? So now to the next part, we will go through the transmission process. So once the carrier wave has been modulated with the audio signal, the resulting FM signal is sent out through the transmitting antenna. So there is an antenna which through the audio signal is being transmitted. The antenna broadcasts the modulated signal as electromagnetic waves, right? So we modulate that audio signal with another carrier wave, which is an electromagnetic wave. So that whole signal is being transmitted. So in this transmission process, this signal is traveling through the air in all directions, so that we can get that signal from every direction. So now the transmission process is over, and now we coming at the reception. So it's a 6 point. At the receiving and radio receivers, such as those in our FM radios, pick up the transmitted electromagnetic waves, the air through their antennas. So we had that FM radios in our house, right? We know about that. So it receives that electromagnetic waves. So the seventh part is demodulation. So we need to demodulate that modulated signal, because there is also an extra electromagnetic wave, right? So what is this in this demodulation? So inside the radio receiver, the process of demodulation takes place. So demodulation separates the audio signal from the carrier wave. The receiver detects the variation in the frequency of the FM signal caused by the frequency modulation, right? So already I have said this. So now what's the eighth part? That is audio reproduction. So the demodulated audio signal is then sent to an audio amplifier to boost its strength. The amplified audio signal is then fed to a loudspeaker or headphones, where it is converted back into sound waves. This allows us to hear the original audio content that was transmitted. So what is this audio reproduction? So this is like we already had that audio signal which is being demodulated, right, from that modulated signal with that electromagnetic wave. So now how we will listen it? We need a we already had an audio source where we put our voice, anything, right? So now it's being transmitted to the air, and now it's also demodulated. Now through a loudspeaker or a headphone, like what we wear in our ears, so through that thing we will listen that. Okay, so this process is audio reproduction from that audio signal to a resource where we will listen it. hmm. So now the ninth part is tuning. In traditional FM radio receivers, tuning is done by adjusting the receiver's dial to match the frequency of the desired radio station. Each radio station broadcasts on a specific frequency, and tuning to that frequency allows the receiver to pick up the corresponding station's signal. So what's their tuning? We have a dial, that black dial, or any color, not like only black. So we rotate it. And there is a label like 98, 99, like this, right? So like we say 98.5 radio FM, anything. We listen about that, right? So that is the station from where the audio signal is transmitted, and our radio that we have in our house, that is the reception, that is from the reception part that receives the audio, and now from that audio receiver we receive the audio, and it reproduced by the loudspeaker or anything. Huh. So we listened it through that, and there we need to tune like on which station we want to listen, 98.5, 98.6, 98.7, anything. So we need to tune that thing, because that's not already set there. Okay. And we change, as we change it, it becomes, and it changes the stations like that sing sound, and then it changes its stations, and by this we can listen every stations in every points with that level and tuning. But in nowadays that in that Android phones or anything, we already have that automatic systems. That's a cool thing. Now the last, not the last part is continuous broadcasting. So radio stations continuously transmit their modulated FM signals through their antennas, ensuring that listeners can access their content at any time when tuned into the correct frequency. That we have already told you, right? So now get to the next part, which is the block diagram of a transmitter. So here is the transmitter, which is already in that stations like uh, a red FM. We know about that. So red FM that had this transmitter, or you can say this transmission system. So they have those big antennas. Hmm. So here is the system. You can see. So here is. Let me show you. So here is the carrier oscillator. Firstly, we need to input the audio from here, reactance in modulator, and then it goes to carrier oscillator and then buffer amplifier, right? From here it goes to the frequency multiplier. Huh. So after this it goes to driver amplifier and then power output amplifier. Through all these systems it go through the modulation system, and after it goes through the modulation system and the audio being modulated, it goes to the antenna and uh, goes to the and traveling through the air. And after this transmission system, what is in the radio where we listen? So there is also antenna. We put a wire or a antenna at the rooftop, right? So from there, the antenna, we don't know very much about these radio things, right? It is a complicated thing. So here is the all block diagram of that thing. So there is a RF amplifier, and from there, from antenna it goes to RF amplifier, and then it goes to mixer, and then a part of that goes to IF amplifier. Huh. Then it goes to FM demodulator. Again, it goes to AFC, I mean automatic frequency controller, and then local oscillator, and then go mixer. Now this is a loop. If there is something like frequency is not setting, then it goes to their mixer. Okay. After the frequency is being set, then it goes to a voltage amplifier. Like there is the demodulator part. Okay. After this FM demodulator, then it goes to the AF voltage amplifier, where the amplifier takes the part of like reproduction of the audio, right? It throws the audio through the loudspeaker so that we listen it. uh, okay. Then it goes to AF power amplifier, so the sound goes clear and much volume, and from where we listen that loudspeaker at the end part of this radio. So that's the end part. Okay. So from this loudspeaker we listen the songs or anything. The like there from the radio jockey what says, right? So now coming to the part that advantages of FM radio. So FM radio broadcasting comes with several advantages that have made it a popular means of communication. So sound quality. Firstly, FM radio delivers high fidelity audio resulting in crisp and clear sound without the annoying static often associated with AM radio. So less interference. That's thanks to frequency modulation. FM is more resistant to interference caused by electrical devices, making it a reliable choice in urban areas with a high concentration of electronic equipment. Also, the last but not the least, wider frequency range. FM radio has a broader frequency range, enabling the transmission of more channels and deliver diverse content. So these advantages are not like too much advantages for us right now because we already have that internet thing. Also, we can see and watch and listen everything from any not like that broadcasting things. We can listen in TV, in internet, everywhere. But with comparing to the AM radio, we can say that there is many advantages in this FM radio, right? So now coming to the engineering aspects of FM radio broadcasting. So here is frequency bands. So FM radio operates within specific frequency bands because they need their specific frequency band. Either they will go anywhere. Like we have walkie-talkie, right? If the FM radio frequency bands matches with those walkie-talkie frequency bands, then we will listen also radios in those walkie-talkie. So it can't be that, right? So the most widely used FM frequency band spans from 88 to 108 megahertz. So this is the frequency band actually. This allocation is regulated by government authorities to prevent interference between stations. So uh, it need to be done. Either it would be gathering everywhere. So transmitters and antennas. Radio stations use powerful transmitters to broadcast signals over long distances. These transmitters are connected to antennas that radiate the electromagnetic waves into spaces, allowing for wide coverages. So now the third is signal processing. The audio signals undergo various signal processing techniques to optimize sound quality and remove noise before modulation. Advanced audio compression methods ensure efficient use of the limited bandwidth. Now the last is receivers. At the receiving end, radio receivers contain circuits for demodulation. Already I have told you that amplification and audio reproduction. We already known about that, right? Knew about it. Sorry. Modern FM radio receivers often incorporate digital features and display metadata like the song title and artist name. I already told you that we can listen from everywhere now, but like in compared to AM radio, it is very good. So there is the advantages. So now, what is this FM radio broadcasting and digital communication things? Like the uh, intermediate that similar things, right? So FM radio broadcasting and digital communication represent two distinct yet interrelated facets and the modem communication landscapes. While FM radio broadcasting has a rich history and continues to a popular medium for audio content delivery, digital communication has ushered in a new era of connectivity, convenience, and accessibility. Let's take a closer look at how these two realms coexist and complement each other. So, FM radio broadcasting is like has been prominent from of audio communication for decades. It utilizes frequency modulation to transmit audio content over radio waves. FM radio has been an integral part of people's lives, offering a diverse range of content, including music, news, talk shows, and live events. Its advantages, such as high sound quality, resistance to interference, and wider frequency range, have solidified its positions as a reliable and beloved medium of information and entertainment. FM radio has played a crucial role in connecting communities, especially in remote or rural areas where other communication options might be limited. It remains a valuable source of information during in emergencies, providing real-time updates and crucial announcements to the public. These things. Despite the advent of new technologies, FM radio broadcasting continues to thrive, capturing the hearts of millions of listeners worldwide. So now, the second is that digital communication. So, digital communication, on the other hand, encompasses a broad range of technologies that facilitate the exchange of information using digital signals. This domain has witnessed remarkable advancements. Thanks to the rapid growth of the internet and mobile technologies, digital communication has revolutionized how people the interact, access information, and consume media. The internet has given rise to numerous digital platforms such as streaming services, podcast, online radio station, everything. Right? So, which have transformed how audio content is delivered and consumed. Listeners can now access a vast array of radio stations and audio content from around the world with just a few clicks. Additionally, podcasts have gained immense popularity, offering on demand audio content on various topics, catering to specific interests and niche audience. So, what's the social impact? Right. So, FM radio broadcasting has left a profound impact on society, contributing to cultural exchange, information dissemination, and entertainment. It has played a crucial role in connecting people, especially in time of emergencies when other communication channels may fail. Right. So, it was all about like social impact. Yeah, we already had that social impact, right? For that FM radio. If we did not grow to that FM radio, we can't be even here in this internet era, right? So now we are at the end of this presentation. So here is my conclusion. We have come to the end of our exploration of FM radio broadcasting in engineering digital communication. Despite technological advancements, FM radio has remained popular, showing its timeless appeal. Let's celebrate its engineering and communication and the nostalgia and charm of FM radio broadcastings. Thanks for joining us. Thank you.